mentioned to me that the y-intercept, which I will abbreviate y-int, is 2. That means it hits the y-axis at a positive 2, which is right about there. And it says right here that the slope is negative 3. If you had to write negative 3 as a fraction without changing its value, you could write it as negative 3 over 1. Do you agree that overall that fraction I just wrote down is negative 3 is really all it's saying? And so remember, slope is, again, the hard part is remember y comes first. So change in y is negative 3. Change in x is 1. The change in y means up or down change. And if it's negative 3, should I go up or down? Down. How much? 3. So from at that point, go down 1, 2, 3. So I'm right here right now. The change in x is a positive one. X is right or left. And if it's positive 1, I should go to the right 1. With slope, the beautiful thing is you can keep doing it as many times as you feel like. And if you do it properly, it should end up. So down 3 over 1. Hey, look at that. Down 3 over 1. So do you have enough points to make a line? Yes, you do. I'll give you a second to make your line, and then I'll draw your attention back up here. So I think you've had enough time. Let's take a look up here. I'm going to write a fraction here, and you tell me if it is the equivalent. Is that negative 3, the way I just wrote that one right here? Overall, does that say negative 3? It does. So could I use that as the slope if it's actually matching the slope that it says up in the problem? It does. But now my change in y is positive 3, and my change in x is negative 1. What that means is to go up 3, left 1. Is that on the same line? Yes, it is. So keep that in mind. What I can't do is that, because overall this says positive 3, which is not the slope we have for this problem. Okay, so keep that in mind. Which means our line is right there. And once again, every point on that line is a solution to that problem. I got 1 on the bottom because I knew I wanted to see a fraction for slope, because I know it's changing y over changing x. And one of the ways you can write negative 3 as a fraction is negative 3 over 1. It doesn't change the value, but it is still a fraction I can see. I mean, we could always do negative 6 over 2, but then you're getting complicated with that. So what I would like you to do right now is don't worry about the problem quite just yet. Just graph that line right there for me. Y equals negative 3x plus 9. You graph that one now, and then we'll graph the other one that they want in this problem together. All right, I think I gave you enough time for that. What form is that line in right there? Slope-intercept, which means your y-intercept is 9, and your slope is once again negative 3, which we could write as negative 3 over 1. Again, whoa. This problem is actually asking for something else, but we're going to graph this line first just so we get a look. So there's 9 right there, and you go down 3 over 1, down 3 over 1. You get the idea. Now, I have made my particular one dashed because that line right there, and you don't have to have yours dashed, that's fine. The reason I did is that line right there is actually not the solution to this problem. And that's why you would make dashed lines in other problems, like when you do inequalities sometimes. Very true, but this is asking for the line that would be perpendicular to the line that you just drew that goes through 3, 0. Did I ask for the equation of that line here? No, that's going to be another day. Today I just wanted you to graph it. I know that it's got to go through 3, 0, which happens to be right there. So if we could just figure out the slope I need to use for that line, we could graph it. And if the slope we have right now is negative 3 over 1, what did we say earlier would make it perpendicular? We have to take the reciprocal, you said, and also opposite. So let's just do the reciprocal right now. If I just flip it, that's what it would turn into, correct? 1 over negative 3. And overall, this green fraction is negative right now, correct? I have to make it the opposite. So to make it the opposite, I have to make it overall positive, which is very simple to do. Well, maybe just hit it when you do it. So positive 1/3 is what I need to use for my slope if I want to make these things perpendicular. And what does that mean? My change in y is 1. My change in x is 3. Both positive, so that's going to be up 1 and to the right 3. Up 1. Right? 1, 2, 3. Okay. There it is. In other words, right there. That's why that one's solid, because that's actually the answer to the question. All the points on that particular line are true to this problem. Do you have any questions? No, I have one for you then. Is that red line in example 3 that I just had come up on the smartboard, would that red line be perpendicular to that red line that is in example 2? In example 2, I have a line that you drew, correct? And in example 3, we just had another line show up, which is right there. Would those two lines be perpendicular to each other if I put them on the same graph? Did you have to put them on the same graph to figure that out? No, you just looked at the slopes. Example 2 was -3. This one's positive 1/3. Definitely perpendicular. Okay? Or you could have multiplied them together to see if you got -1.